At the end of this video, you should be able to convert measurements into scientific notation. Chapter 2, Section 3, Scientific Notation. In scientific notation, numbers are written in the form m multiplied by 10 to the nth power, where the factor m is a number greater than or equal to 1, but less than 10, and the power of n is a whole number. For example, to write the quantity 65,000 kilometers in scientific notation and show the first two digits are significant, you would write 6.5 multiplied by 10 to the fourth kilometers. Writing the m factor as 6.5 shows that there are exactly two significant figures. If instead you intended the first three digits to be significant, you would write 6.50 times 10 to the fourth kilometers. When numbers are written in scientific notation, only the significant figures are shown. Suppose you are expressing a very small quantity, such as the length of a flu virus. In ordinary notation, this length could be 0.00012 millimeters. That length can be expressed in scientific notation as is shown on page 51 of your text or on the screen now. 0.00012 millimeters is equal to 1.2 times 10 to the negative fourth millimeters. We move the decimal point 4 places to the right and multiply the number by 10 to the negative fourth. 1. Determine m by moving the decimal point in the original number to the left or right so that only one non-zero digit remains to the left of the decimal point. 2. Determine n by counting the number of places you moved the decimal. If you moved it to the left, n is positive. If you moved it to the right, n is negative.
Scientists sometimes need to express measurements using numbers that are very large or very small. For example, the speed of light through space is about 3 billion meters per second. 9 zeros is a lot of zeros to keep track of when performing a calculation. You can express values as a number multiplied by a power of 10. This is called scientific notation. There are 9 decimal places to the right of the 3 in 3 billion. So using scientific notation, the speed of light through space is written as 3 times 10 to the 9th meters per second.
Mathematical operations using scientific notation. Addition and subtraction. These operations can be performed only if the values have the same exponent, or n factor. If they do not, adjustments must be made to the values so that the exponents are equal. Once the exponents are equal, the m factors can be added or subtracted. The exponent of the answer can remain the same, or it may then require adjustment if the m factor of the answer has more than one digit to the left of the decimal point. Consider the example of the addition of 4.2 times 10 to the fourth kilograms and 7.9 times 10 to the third kilograms. We can make both exponents either 3 or 4. The following solutions are possible on page 51 of your text or on the screen now. But note that the units remain kilograms throughout. Multiplication. The m factors are multiplied and the exponents are added algebraically. Consider the multiplication of 5.23 times 10 to the 6th micrometers by 7.1 times 10 to the negative 2 micrometers. Note that when length measurements are multiplied, they result in area. The unit is now micrometers squared. Division. The m factors are divided, and the exponent of the denominator is subtracted from that of the numerator. Note that the unit for the answer is the ratio, in this case, of grams to moles. At this point, you should be able to convert measurements into scientific notation.